by proportional method. We decided the formula for small ni equal capital Ni divided by capital N multiply small n. Small n stand for total sample size. So we have a knowledge about total sample size, but how much should be taken from strata 1, from strata 2, and so on, that is not known. So we decide small ni such that it will be proportional to stratum size. So small ni proportional to capital Ni. Under this assumption, we derive the formula and it comes as small ni equal capital Ni divided by capital N multiply small n. And it is repeated for I1, 2, 3 up to k. After replacing this Ni in the variance formula of y bar st, your variance is simplified like this, which is on the screen. So this is your variance of y bar st under proportional allocation. Formula comes n capital minus small n divided by capital N into small n multiply summation I1 to k wi si square. If you look, original formula of variance of y bar st without allocation, the formula is summation I1 to k inside ni capital minus small ni divided by capital Ni into small ni multiply wi square si square. And that original formula simplified like this. So this is the formula to get a variance of unbiased estimator of population mean in case of stratified random sampling, in particular with proportional allocation. Today we'll proceed ahead how to decide small ni by Neyman's allocation. Neyman was a statistician. He suggested this procedure. In this case, we allocate sample of size ni for ith stratum such that variance of y bar st is minimum for fixed total sample size. So this is the assumption of Neyman allocation. What it says? It says try to decide the value of ni. How? Such that your variance of y bar st, y bar st is nothing but unbiased estimator of population mean under stratified random sampling. So I want to decide ni which provide variance minimum with condition sample size is fixed. That means small n is provided to you. So I write this statement of Neyman allocation in mathematical form like this. Phi equal variance of y bar st. I want to minimize this function plus lambda time the condition on the minimization. What is the condition? Small n equals sum of ni. So under this condition, small n is equal to this. So this bracket is a 0. 0 multiply lambda is 0. Ultimately, phi is a variance. So I decide a value of ni such that my variance will be minimum. That is why this is your algebraic equation under Neyman's allocation. Put the formula of variance of y bar st, which I just now told you. This we derived in previous classes. Summation I1 to k, ni minus small ni, total divide ni multiply ni, wi square, si square, plus lambda is a constant unknown which is decided. Summation ni minus n bracket complete. Now I split this first quantity for simplicity of further calculation. What I did, I multiplied wi square si square inside this. This bracket is written as 1 upon small ni minus 1 upon capital Ni. So wi square si square with small ni minus summation wi square si square by capital Ni. I think you understand what I want to say. This is nothing but 1 divide small ni minus 1 divide, this is capital Ni. So if you solve this bracket, this Ni goes here minus small ni divided by Ni into Ni. So this bracket is written separately like this. So in the next step, wi square si square multiply this first term is a first quantity minus summation I1 to k wi square si square multiply this gives this much. So this is nothing but simplification. Why we get this type of simplification? So after this, we go ahead plus lambda times summation I1 to k ni minus n. Now in calculus, if you want to minimize the function with some variable, then we differentiate that function with variable under study. This everything we are doing to decide the value of small ni. So quite natural, I will differentiate this function with ni. So I wrote differentiate both sides with respect to ni, we get dabba phi upon dabba ni. We have two type of differentiation. One is a total differentiation, another is a partial differentiation. When I write a dabba, it is a partial differentiation. That means only ni is a variable. The remaining things are constant. If I write capital D, then it will be total differentiation where everything is variable. So here we will not take a total differentiation, we take a partial. And that is why in the first term there is ni. In second term, there is no small ni. That's why differentiate directly 0, because differentiation of constant always 0. Plus lambda time summation get cancelled. Differentiation of ni with ni is 1. Differentiation of n with ni is 0. Now here you can think differentiation of particular I, so summation will be dropped. Wi square as it is, Si square as it is, and differentiation of 1 upon Ni is minus 1 upon Ni square. It's to be remembered. This is a differentiation of 1 upon Ni with respect to Ni. So next line, lambda into 1 is lambda minus Wi square Si square upon Ni square. I equate this differentiation to 0, that means this equal to 0. So you get naturally lambda equal to Wi square Si square upon Ni square. Now from this equation, you can try to find Ni. Take Ni square on the left side, lambda goes to right side, and then take the root of Ni. So Ni become Wisi root lambda. Call this equation 1. Now here easily you can see this lambda is a constant. So 1 upon root lambda, I say proportional. So when I want to write equal without constant, then I use this symbol. So what this equation says? It says that your stratum sample size directly proportional to WISI. What is WI? It is the weight for ith stratum, capital Ni upon capital N. So if I put it here, capital N is again a fixed. So it is a new constant that is absorbed with this proportional symbol. So Ni directly proportional to capital Ni multiply capital Si. So what the neyman's allocation says? Under neyman allocation, we decide stratum sample size which is proportional to the stratum size capital Ni and with variation, standard deviation of that strata. So we find proportional constant lambda in this equation. If I get the answer of lambda, I will get the formula for Ni under Neyman's allocation. Let us see how to decide a lambda. We find proportional constant lambda such that total sample size equal to sum of Ni. Why it is so? Because we start our procedure by assumption. What assumption? The total sample size should be fixed. So I want to decide proportional constant root lambda such that my total sample size will be fixed. Summation I1 to k, we got this Ni. Ni is Wisi root lambda. Now take a root lambda on the left and n on the right. So I get root lambda equal summation Wisi upon small n. So I got the value of root lambda that I replace in equation 1. Hence, the Neyman's allocation says Ni equal Wisi. It is the value of root lambda. N goes to numerator. So n time Wisi summation Wisi under Neyman's allocation. Ni can be replaced, excuse me, hello, hello. Wi can be replaced as capital Ni upon capital N. So, हेलो, बोलिए। वालेकुम सलाम। नहीं ना, वो 10th सर्टिफिकेट सर्टिफिकेट नहीं मिल रहा है, वो स्कूल में दिए थे ना, तो उसके उसके बजाय 10th का सर्टिफिकेट दिया है डेट ऑफ बर्थ के लिए। जी 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 जी, हाँ 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 हाँ। अच्छा, तो देखना पड़ेगा वो हाई के उसके पास, मैं बोलता ढूंढने को। हाँ 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 हाँ। ठीक है, मैं 12 का देखता हूँ उसके पास हाई के लिविंग, क्योंकि ये सबमिट करते हैं ना अपन इंजीनियरिंग को वगैरह। हाँ 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 हाँ, चलेंगे चलेंगे, जेरोक्स देखता हूँ मैं है क्या। आपके व्हाट्सएप ग्रुप है ये आपका? तो नहीं, फिर उसको क्या पे भेजने को बोलूँ? हाँ हाँ हाँ, अभी मैं कॉलेज में है, थोड़ा एक आधे घंटे से भेज चलेंगे क्या? ओके ओके। हाँ हाँ, ओके ओके, चलेंगे, मैं कॉल करूँगा। जी, अस्सलाम वालेकुम। So here, if I replace Wi as Ni upon capital N, you get a new formula in terms of Ni. Just replace Wi to Ni, N get cancelled. So you have two formulas of Neyman's allocation. Small ni equal n multiply Wisi divided by summation Wisi, or small n multiply capital Ni capital Si divided by summation I1 to k capital Ni capital Si. Now under this allocation, what will be variance of y bar st that we want to derive, and then we'll stop. Variance of y bar st under Neyman's allocation. We have variance of y bar st which is original like this under original stratified random sampling. Now I can simplify this entire quantity in two terms. So this everything which is the original variance of y bar st under stratified can be written in this simplified form as a two terms. Summation wi square si square upon small ni. Just now I explain you. Minus summation wi square si squared upon capital Ni. The reason behind to this is, now we want to replace formula of Ni in this place of Ni. That will be answer variance of y bar st under Neyman. Let us proceed ahead. Summation I1 to k wi square si square divided by Ni. So it is a reciprocal of this formula because it is in the denominator. So it is written as summation wisi divided by small n wisi. These cancel with square in the numerator. So when I take a summation, it become a one value. So it is a constant after taking summation. So summation WISI, again summation WISI become summation WISI square divided by small a minus summation WI. Now here 1 WI is Ni upon N. So this Ni get cancelled and you get only one Wi there. So Ni replaces as capital N. So summation Wi Si square by capital N. So this is my formula of variance y bar st under Neyman's allocation. Excuse me. वालेकुम सलाम. जी. अच्छा. 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 साइन मेरी स्टूडेंट की कि मेरी. जी जी हाँ. जी हाँ. चलेगा चलेगा चलेगा. ओके ओके. ओके ओके. थैंक यू. ब्लू पेन ना. हाँ हाँ. ओके ओके. चलेगा जी. So this is your variance of y bar st under Neyman's allocation. Today we'll stop at this stage. Tomorrow we'll see third method of allocation.